Question 6 is coming from binomial expansions. In the expansion of this one here, it is given that the coefficient of x power 4 out of the coefficient of x is equal to 3. Find the possible values of the constant a. Now, we need to find the term in x power 4. So, this one will be n combination something. We have two terms, x over a, and then the other one is a over x squared. Now, these ones are going to move, the powers are going to move like this. This one will first begin with power 7, then 6, then 5, 4, 3, 2, 1, 0. It will have 8 terms. And then the second one here starts from 0, 1, 2, 3, 4, 5, 6, 7. Okay, so they move in pairs. If the first one is to the power of 6, the next one is to the power of 1. Okay, I don't need to expand the whole of this for me to pick out this and this. I just need the two terms they are talking about. Okay, so I need to put a pair from here such that it ends in x power 4. If I put 7 and a 0 here, automatically we shall have x power 7. Of course, this one is 0, so that one will end in x power 7. So that one will not work there. If I put 6 and 1, we shall have x power 6 out of x power 2. Not so? This one will end in x power 4. So that means that is what we are supposed to have there. 6 and then 1. Then the power of this second one here is the one that we put in the combination. 7 combination 1, that is a 7. Then times. This one will be x to the power of 6. Divide by a power 6. Then times a power 1 out of x power 2. And this one, I would simplify it to 7. This one is a, this one is a power 6, so that will be a power 5 down. So that will be 7 over a power 5, then x to the power of 4. Okay, so the coefficient of x power 4 is this one here. And then, how about the term in x that ends in x? Again, we shall have 7 combination something here. Then we have x over a, and then here a over x squared. So we can pick another pair, maybe 5, 2. If I put 5 here and a 2 here, we shall have x power 5. Then this one will end in x power 4, right? And then when these ones reduce using the rules of indices, automatically you will get x as the one that remains. So meaning we shall have our x there to the power. We shall have x power 5, the first one here, and then the 2 here. So that is that. Now the power here is the one that comes here. So we shall have a 2 here. Now what is 7 combination 2? 7 combination 2. That is 21. So I'll put 21 here. Then times, this will be x power 5 over a power 5 times a squared over x power 4. So simplified, this one here, 5 minus 2, that will be a 3. So we shall get 21 over a power 3, and then x when this one and this one reduce. Okay, so that is what we are having there. Now they say that the coefficient of x power 4, coefficient of x power 4, when you divide it by the coefficient of x cubed, then we get, it's not cubed, sorry, of x, then we get a 3. So we shall have 7 over a power 5, then we divide by 21 out of a power 3, then this one should be equal to 3. Using the rules of fractions, we shall somersault the the one in the denominator, so a power 3, then out of 21, which is equal to 3. So this one will go here 3 times. So in other words, of course, this one will reduce with this one. The whole thing will be 1 over 3 because 7 goes in here 3 times, okay? So 3, then a power 2, which is equal to 3. When we cross multiply, we shall get 1, which is equal to 9a squared. So 1 over 9, then will be equal to a squared. And therefore, we shall take the square root on both sides, plus or minus, that will be our a. Remember, when you take the square root, you get plus or minus. And here they said possible values. You see, if you don't put plus or minus, you're going to have only one value. So our a is therefore going to be plus or minus a third. As simple as that.